whether it's a paper cup you're drinking your coffee out of or the car that you drove to get there, an engineer was involved. And that is really an awesome thing to be a part of.
Hello and welcome to another exciting episode of the Being an Engineer podcast. Today we're joined by Andy Thompson, a seasoned mechanical and manufacturing engineer renowned for his expertise in GD&T. With over 2 decades of hands-on experience, Andy has progressed from CNC operations to leading structural engineering teams. His passion for precision and continuous improvement makes him a supremely valuable and sought-after voice in the engineering community. Thanks so much for being with us today, Andy.
Hey, yeah, thank you, Aaron. It's great to be here. Looking forward to it.
Me as well. I've been looking forward to this conversation. So tell us, what made you decide to become an engineer?
Yeah, so I kind of initially started my career as a machinist and worked for it was a contract manufacturer, job shop. And we dealt with a lot of different customers, a lot of different industries, a lot of different types of product. And, it came pretty obvious to me early on that I really enjoyed that kind of work, building things, making things, solving those kind of problems. But I wanted to be involved solving problems at an additional level beyond that. I wanted to get into the design realm. I wanted to help solve some of these problems more than just on the shop floor after they've started. I wanted the chance to kind of solve them before they happen, so to speak. So it drove me towards engineering at that point.
Terrific. That your experience machining is so valuable. I wish that all engineers could have that experience. I had nowhere near as much as you did, but I did spend a summer basically as a light machinist on a manual mill and a manual lathe, designing and then making my own fixtures. And it was so helpful, to get a real sense for how parts are made, because as a designer, it's immensely valuable. What was your favorite part about being a machinist?
Really just building kind of from scratch, right? You start the day with a sheet of paper and a chunk of metal. And, you go to your machine, you figure out the process, you get the tools that you need. When it's all said and done, this thing that was nothing more than an idea is now a reality. It's high precision. It's very creative work. It's very difficult work. And so, having that at the end of the day to look at a cart full of parts or one part that's maybe even taken weeks and say, I created this. And be able to wrap your hands around that and verify, and then see it go into an assembly, go out and function and perform some thing out in the world that it was designed to do is immensely rewarding. And it was incredibly fun to be on that side of the manufacturing of it, right?
It sounds just incredibly fulfilling, right? To see, I think that's one of my favorite parts about engineering is that eventually you get to see the part, the assembly, the product in your hands, right? You hold it, you use it, and hopefully it's performing some kind of useful feature or work. And as a machinist, you got to see that like every day, right? These new parts that you just created from a hunk of metal. Do you remember what was the most challenging part that you made?
Oh, yeah. Yeah, there's a couple that stand out. I had one particular for an aerospace company, a very large part made out of a big, I want to say 10 to 12 inches diameter in titanium.
Wow.
12, 14 inches long. And, the chunk of material itself was several $1,000s. The shop owner walked by and reminded me that it was a very expensive piece of material. Don't mess this one up.
No pressure.
Yeah, no pressure. Just get it right the first time. And, the tolerances that were on it, the geometry that was on it, it took weeks, roughing the part out, making sure nothing went wrong. Titanium sensitive to temperature. So make sure we're not doing anything that's going to change the state of the metal, right? Doing anything that's going to cause problems down the road. So that was by far my most memorable part that came out for a single part.
Wow.
There were other aerospace parts that we made that were, maybe not quite as difficult or as intricate, but very difficult, and to build a process around it, right? So to build something one time, is a different challenge than to say we have to build a process to build hundreds or thousands of these, and we have to do it repeatably, and we have to do it affordably, right? They take a different mindset. They take a different mindset in design, and they take a different mindset in manufacturing. So seeing both sides of that was really rewarding and really educational.
Well, eventually your journey from machinist to engineer led you into the realm of GD&T, geometric dimensioning and tolerancing. Tell us a little bit about that. How did you find yourself in GD&T? And you really are an expert, a trusted voice in the community at this point. How did you get there?
Yeah, so as I started as a machinist, seeing all the different products, all the different designs coming from different customers, different industries, and seeing everyone using GD&T differently, and rarely was it used correctly, kind of drove me towards really digging into the skill set for myself. My employer at the time arranged a pretty basic course with a local person to come in for a few nights during the week and give us some kind of high level training so that we had some understanding of it. And that's really all it took for me. I was hooked from that point forward. And, seeing the power of it, what it could do if used correctly, seeing how often it was used incorrectly. I was able to connect with that instructor. He kind of became my GD&T mentor, right? And he started walking me through the standard, helping me understand it. And kind of from that point forward, just years and years of reading the standard, looking at drawings, looking at parts, figuring out what it means from a design perspective versus manufacturing versus inspection. All those different aspects all play into that one standard, and kind of how they play together was just super fascinating. So I've spent a lot of time digging through it, studying it, conversing with people. How about this? What if this? And honestly being wrong about a lot of different things and figuring out why I'm wrong and working to fix it. So
you mentioned that, I think this was during your time as machinist. Oftentimes engineers would use GD&T incorrectly on the drawings. What are some of the common mistakes or misconceptions that engineers have about GD&T, and how do you address those?
Mm-hmm. So some of the common misconceptions first are, if you see a drawing that's fully defined with GD&T, it automatically kind of causes some people to panic. You've overcomplicated something, right? And so this can drive people away. And this is really, couldn't really be further from the truth, right? When we're looking at fully defining the variation allowable in a part, right? Let's just take a very quick example. And let's think about just a cylindrical shaft that has a couple of different diameters on it, right? And we think about a drawing that doesn't have GD&T. It's going to have the couple of different diameters and their tolerance is called out. And that's pretty much all it's going to say, some lengths in there. And, shops are going to look at this and they're going to put it on a lathe and they're going to turn all the diameters at the same time. And the coaxiality error between all of these diameters is going to be very tightly controlled because of that process. Right? We turn everything at one time, very tight coaxiality control. But something changes and maybe we have to do it in two setups. We have to work on one side, stop, flip it around, do another side. Now from one side to the other is going to have higher coaxiality error. Or let's take this a step further, and maybe all my lathes are busy, but my mills have time. And geometrically, I can create this part. I can hit the tolerances that are provided on my mill. So I take it on my mill and now I mill these features. Well, it's still going to be, still precision machining, but there's going to be a greater coaxiality error in the milled part versus the turned part. How much error is there? It hasn't been defined on the drawing. And now we have parts that we inspect, meet all of our diametrical tolerances, but they don't assemble. They don't function. Something's wrong. We haven't even checked for coaxiality error because it wasn't on the drawing. We don't know how much is allowable and still have our part function. A fully defined product with GD&T tells us how much variation is allowed on every feature, right? So that shouldn't intimidate someone. That should really make them feel good about the fact that I know what is allowable on this part. I know every state of good versus bad. It's been defined. I have to learn how to interpret that, but now I know what makes a good functional part. And as a designer, I know what has to be defined to communicate that. As a manufacturer, I know how to integrate that into my process. And as a quality inspector, I know what needs to be verified to make sure this part's going to work the way it's intended.
From motors and robotics to controls, automation, and precision prototyping, Simutech brings ANSYS simulation tools and expert insight directly to your team. We help you accelerate design, reduce risk, and eliminate costly rework.
Validate before you fabricate. Simutech Group helps you simulate thermal stress, vibration, fluid flow, electronics cooling, electromagnetic performance, you name it.
Whether you're in automotive, aerospace, energy, industrial automation, or the next big thing, Simutech partners with innovators to deliver simulation-driven results that move products forward. Build smarter machines, launch stronger products, scale faster with Simutech's simulation support by your side.
Simutech Group, your engineering partner in motion. Visit simutechgroup.com and let's power up your next design.
So let's talk about those three areas: design, manufacturing, quality. They're three sides of the same coin, really. How does GD&T tie them together? Is GD&T a tool or language that can be used to collaborate between those three disciplines?
Absolutely it is. And that's really, I think, one of the big reasons why I latched onto it so early on is working in manufacturing and trying to work with design to really understand what's going on, right? It's that language that tells us what we could do in pages and pages of notes and explanation and papers to say with a few symbols, right? Once we understand things, right? So that tool becomes the common language that all three different worlds are speaking about the same part. Right? They may be thinking about things from a different perspective. My design brain tells me I have to make sure that these two parts always fit together every single time. My manufacturing brain says I need to make sure I have these features tied in and done maybe in the same operation or with the same tool to avoid any potential variation between the two of them or to greatly reduce that potential variation. My inspection brain says I'm going to need to make sure that I have some type of fixture that adequately sets up on my datum reference frame, that is my datum feature simulator to start verifying this data from. This is going to mimic the part in the assembly and tell us accurately what it's going to look like to the mating parts.
You talked about sometimes a part can be machined to the specifications on the drawing, but maybe those specifications didn't quite have the right design intent behind them, whether it's with GD&T or something else. Mm-hmm. Can you think of and share an example of when you or someone else on the team was able to apply GD&T and that application of GD&T, moved the needle for the project, the process, the component, whatever it was?
Yeah, I mean, there's two really good specific examples for this. We had one. Again, this was at the machine shop, but a customer had brought us a new housing manifold kind of part that they had. Big, tight tolerance part, expensive part, fairly complex in geometry. And their drawing was terrible. Their GD&T, if there was a GD&T rule that existed, they broke it. And they did it consistently. And
as they were consistent,
they were very consistent, and that was helpful. And as they had taken this part to other suppliers, they would try to qualify them. They would have them build 5 parts at a time, take them back and test them. And never would there be more than 2, maybe 3 parts that would ever function for them. And they finally brought this to us, and we sat down with them. And the first thing we tried to talk to them about is how terrible their drawing was. And sometimes when the manufacturer, the supplier, is going to the designer, the customer, and says, I think there are problems here, that's not always well received. And that's just part of the reality of the industry that we're in. So instead, we focused on, learn what the part is intended to do. We we had them walk through the assembly process, its functionality, how the different parts mate together, what their interfaces are. And we kind of took it on ourselves to make our own GD&T version of the drawing. And then we sat down and built our manufacturing process around it. And we built our 5 parts, sent them to the customer. All 5 parts worked fantastically.
Wow.
And we were able to start, we built hundreds and hundreds of these parts to our modified drawing, because when we tried to do it off of theirs, nothing seemed to work.
Phenomenal. Did they ever come back at the end and say, wow, clearly GD&T is something we should learn better. Can you teach us? Can you help us?
Unfortunately, they didn't. They took their win and left for the day, I suppose you could say. But, we were able to make the parts and move on. So
that's awesome. What a great experience.
Yeah. And, I've had a similar time it was actually a defense contract. The parts, the drawings were actually drawn. GD&T was done exceptionally well. The existing manufacturer didn't understand GD&T. And so they weren't integrating it into their process. They were having quality issues. They had scrap problems. They had delivery problems. And so when we sat down and looked at the very well done GD&T and built it into the manufacturing process, used their datum reference frame as our fixture points when we could. When we couldn't, make sure that we had control dimensions or ways of fixture to control our variation. When we utilized the tool of GD&T properly, our manufacturing process came together magnificently and, built hundreds and hundreds of parts with this setup with no quality issues to the best of my knowledge.
Wow. That's amazing. You obviously have spent a lot of time with design and manufacturing, design for manufacturing. What are some of the places that design engineers commonly stumble, and how could they fix this with GD&T?
Yeah. So, GD&T is a tool like anything else, right? And so used correctly, it by itself doesn't necessarily solve manufacturing issues outside of telling the manufacturer how the part works together. But things within the design, let's take a machine part for an example, and we have a machined pocket with sharp corners, right? This is a common thing that we see happen all the time. It's not impossible to make. We can put it on some type of a sinker EDM, make it die, put it in there. Cost you 10 times as much, take 3 times as long, but it can be done. If your product requires that, and it's not done because someone didn't understand it, it's certainly worth doing. But those type of design for manufacture processes are handled through any other kind of design process that you'd have, right? A collaborative design methodology starts with talking with your stakeholders, talking with people involved. If you're in design, talk with manufacturing, talk with inspection. And it doesn't have to be a formal 2-hour meeting with 50 people in a room arguing and never getting anything done. It can be as simple as having some back and forth conversations very early on in the process, right? Understand what your intent is. Talk to them. They're going to tell you some things like, hey, make sure you don't do this. Make sure you try and do this, right? Just those simple conversations up front can save hours and hours and sometimes weeks and weeks. But that type of relationship building, that collaboration is a tool like anything else that engineers can use to improve their process, no matter what side of the gate they're on, whether it's design, manufacturing, inspection, even procurement for that matter, right? With supply chain issues that we've seen very prominent, picking the right material sometimes can change the ball game. So make sure these conversations are had, at least at a very fundamental level. And I think you'd be surprised at how quickly it changes the results that you're getting.
How do you know if your shop really understands GD&T? Because like you said, not all shops do, right? So let's say that your team is like this customer you had, excellent at GD&T, you get it all right, the language is clear, and you send it off to a shop. And if they don't know GD&T, well, the what do I call this? the sentiments that I have heard from engineers is that they don't like using GD&T because it makes the parts more expensive, because the shop sees it and they automatically think to themselves, oh, this is super high precision, which you've already debunked is not necessarily the case. But perhaps a shop that doesn't have a lot of experience with GD&T might think that, or they might just, say, great, no problem. We can do this. We understand all the GD&T, but they don't really. Any pro tips for like auditing your shop to see if you really know what they're talking about?
Yeah. First thing is, what you just mentioned, right? If you show them a GD&T drawing and they go, oh, this is really overcomplicated, that should be your first red flag, right? Your manufacturer should be ecstatic that you have fully defined the part in GD&T, because now they know what they need to build, right? Now, I say ecstatic if you're using GD&T correctly. If you've slapped a concentricity tolerance and a block tolerance on something and said, hey, now it's fully defined, that's not using it correctly. That's not doing it well. And I understand why people swear about that. So some of the other tips that we've seen, and this actually came out in a meeting I had somewhat recently, a little less than a year ago. Someone talked about they made a product, or they made a part, a drawing with two different tolerances on it. There's a concept in GD&T called 0 at MMC. Essentially what it does is it ties the size of a clearance feature in with the relationship of the position of the clearance feature. And it says, as long as you protect a boundary, you can vary size or position all you want within this boundary. It's a fairly simple concept once you understand it. But on the drawing, it shows a 0 at MMC tolerance. So people that don't understand GD&T see a 0 tolerance. You'll get no quotes. You'll get insanely high quotes, when in fact you have maximized the allowable tolerance for them. You've done one of the best things you can do in a clearance application. That doesn't mean 0 at MMC is that, solution to every problem. But for that particular case, it's a great tool to help understand. And so in conversation, he sent out one drawing that had the typical tolerances like you would expect to see, a size and position tolerance that were separated, and another that had 0 at MMC where they were all tied together, and see who comes back with either no quotes or better prices with 0 at MMC, right? And it kind of helped to define, okay, these guys at least have a fundamental understanding of GD&T.
Yeah.
And, we can start to work with them.
Clever. Nice.
Right? And obviously, those kind of things, I don't know if you want to call them trickery or not, but there's ways to kind of test people. Honestly, conversations can reveal it very quickly, right? If you have a person knowledgeable in GD&T, you can start talking about how certain things are done when they have these types of call-outs. How do they treat them? What do they do, right? Those kind of things can be pretty telling about how well they understand it.
Yeah. Yeah. Are there situations where GD&T should not be used?
If you're building a house, maybe.
Okay. So effectively, you should be able to use it for any kind of precision part.
Any type of precision part, and especially one where you're going to have any type of mechanically driven interface, right? Where you have, component A inserting into component B, and it either has to have interference or it has to have clearance or has to be able to move in some particular way while it's in an assembly, or we have to be able to say, we have all 10 parts bolted up and there's a hole on the top and a hole on the bottom, and they have to be able to do the same thing at the same time, right? This is the power that GD&T brings, is it allows us to evaluate that and make sure that functionality is there.
Terrific. All right, Andy, I'm going to take a short break here, and I want to plug the wave.engineer. A lot of you have probably heard me mention the name at least, but may or may not have visited the site. Just type in the wave.engineer and you'll pull it right up. There are all kinds of really cool, useful tools that we've got there. There are forums and articles and things like that, but there's also a page of mentors. These are senior engineers who have agreed and are interested in mentoring younger engineers. So you can connect with a mentor on the Wave. There are CAD downloads. We call them our design accelerators. These are it's kind of like the no-code version of CAD design, where it's a mechanism, for example, or some type of component that's already designed and can be applied in a variety of situations. Drop that into your assembly and speed up your design process. One of my favorites is there's a device holder. So if you need to hold a device for, in a fixturing or some kind of test environment, we have a device holder file that you can very quickly update to accommodate your specific component geometry. And so anyway, there are a host of different tools and educational content on the site. There are past webinars that we've recorded on GD&T and other things as well. So check out thewave.engineer if you haven't already. Moving on, we are privileged to be able to speak with Andy Thompson today, GD&T and engineer extraordinaire. So GD&T is, like many things in life, it's not stagnant. It changes over time. How do you stay current with the changes in these engineering standards?
A lot of it is just taking the time to read the new revision, understand the differences between them, and understand the world that these standards live within, right? I recently attended the ASME committee meeting here a few weeks ago, and I don't think even with the work that I've done, had a full grasp of the depth of the world of the ASME standards that are out there. And there are, they exist for so many different industries, for so many different applications, and the people, the true experts that are there in developing and maintaining these standards, are truly experts in this type of a field. First time in a long time I've been in a room like that where I truly felt like the rookie when it came to my knowledge of standards, because these people truly put me to shame. But taking that time to read, understand, you mentioned, kind of find some mentors here, right? Find people that are experts in that. And for the most part, if someone has taken the time to really gain expertise in a field, they love nothing more than talking about it. So engage them in conversation, help you learn where the changes are and how to stay up to date and how to use them, right? So networking, communication, collaboration are some of the biggest tools you can use to stay current with that.
You seem to me that you're pretty skilled with networking. I mean, I see you on LinkedIn. I see your posts on LinkedIn. It seems like you're pretty well plugged in to the community there. How did you start doing that? Because a lot of engineers, right? We want to go in a dark room, close the door, and just sit and be by ourselves on the computer. I know I definitely have times when I feel like that's what I want to do. And it can feel a little uncomfortable to kind of come out of our shells and put ourselves out there a little bit. Did this always come naturally to you, or did you have to work on it? How did you make that happen for yourself?
No, I definitely think there's a similar part, of my personality. I just leave me in a room with a computer and a calculator and let me just do some cool stuff, right? I definitely want that. But at the same time, like as you start, like I said, once you start engaging with people in the field and you get in contact with these very passionate people about the same subjects that you might have a passion or curiosity about, it's so much easier to break down those lines of communication, right? I don't have the ability to go to a business conference and talk about business for 2 days because it doesn't have that much interest to me. But you put me in a room with other mechanical engineers talking about GD&T or other types of tolerancing, inspection, manufacturing, the same things I'm passionate about, and it becomes very difficult to shut us up, not to start the conversation. So, find people of similar interest to do that. And then, for let's say the social networking side of it, right? While LinkedIn is considered a professional network, there's certainly that social network aspect to it. That really came about a little less than a year ago. And it honestly started with that same conversation that I talked about, where someone talked about using Zero at MMC to prove out their suppliers. I had never heard of someone doing this. And, within my internal network, I had talked about it a little bit, and I was really kind of curious how this was being viewed in the world at large. So, I mean, where else do you go to find opinions from random strangers but the internet? So put it on LinkedIn, and for as technical as the content was, I got a very high amount of reception. A lot of people engaged with it. They read it. There was comments on it. It was shared. And it really kind of surprised me. And here a few months later, I had a similar question. I don't remember what it was. And so I tried it again. I put it on LinkedIn, and very similarly, it was very well received. A lot of people responded, commented, engaged with it. And I found people reaching out to me to ask questions about what I was posting. And so it just, it took a few times, but it evolved into these weekly posts talking about very technical subject matter that I really never thought would get any type of engagement on any type of social platform. And it's been very well received. It's been really a lot of fun to engage with all kinds of different people. I get to learn things from different subject matter experts in different design fields, different types of products, both in design, manufacturing, process, and have these types of conversations where anyone who wants to participate can come and learn, can join the fun and grow their skill set or help others grow their skill set, right? So to see that type of participation on such a technical subject has been great fun. And so that's why I've kind of continued, at least, I try to at least once a week put something out there that hopefully sparks, drives conversations and questions.
I love that. I love the idea of just helping other engineers. I think that engineers are the superheroes of our world. I mean, really, genuinely think about everything that we maybe take for granted, but have around us and contribute to our quality of life, our human experience. 90% of that was developed by engineers, right? The cars that we drive, the infrastructure that we enjoy, the fan that cools us down, the phone we use to communicate with our loved ones and connect with other people. All these things were developed by engineers. And I just think that engineers are, I don't want to say undervalued, but I don't think the world knows us well enough. The world doesn't understand what engineering has brought to our society, to our species. Mm-hmm. So I appreciate everything that you're doing out there, Andy. Just building up the community and helping younger engineers and maybe older engineers as well understand the tools better and helping them get better at designing and developing things that will continue improving our human experience. The Product Development Expo, or PDX, is your chance to learn from subject matter experts providing practical, hands-on training for dozens of different engineering topics. GD&T, Advanced Surface Modeling, DFM, plating and finishing techniques, programming robots, adhesive dispensing, prototyping tips and tricks, and lots more. PDX happens October 21st and 22nd in Phoenix, Arizona. Learn more at pdexpo.engineer. That's pdexpo.engineer.
Yeah, I absolutely agree. It's really fun to sit and think about this. We take drives in our cars and my wife will yell at me because I'm gawking out the window at a power pole or an antenna tower, or just some random thing and start to talk about, the hours of engineering time that had to go into this that nobody has thought about, right? Look at a stoplight, right? Hanging at your intersection, and we curse when it turns red. And you sit there and look at it while the wind's blowing and it bobs up and down 6 or 8 inches because of the strain involved with it, and think about the amount of time that had to go into calculating the joint strength, the stiffness of the material, and the fatigue life that this thing experiences over 50 years of sitting there bouncing in the wind. Someone had to sit down and figure all that out and make sure it works.
Yep.
And every single product that you look at has something similar involved with it. Whether it's a paper cup you're drinking your coffee out of or the car that you drove to get there, an engineer was involved, and that is really an awesome thing to be a part of.
I could not have said it better myself. Phenomenal. I have this habit of looking at, especially earlier in my career when I was doing a lot more with plastic injection molding design, I would look at consumer products, plastic parts, right? And kind of analyze how they were made. I would look for parting lines, and I would look for, indications of where the shutoff was and side actions and things like this. And, after my wife and I got married, we'd take walks around the neighborhood. That was our thing. In the evenings, we'd take a walk around the neighborhood. And one of these times I had something with me. I don't know, it was a water bottle or something. And I was looking at it and inspecting it. My wife, she turns to me and she says, "What are you doing?" And I said, "Well, I'm trying to figure out, like how this was made and how the geometry was created and what manufacturing process was used." And she looked at me like I'm an idiot. She says, "It's plastic. That's all it is. It's plastic." This gross oversimplification, which, I don't falter. But I think that is, just like anyone would think or any discipline in which they are not an expert, you just don't have the appreciation for it because you haven't learned about it. But, anyway, I'm starting to ramble at this point.
It's very much there. And I think a lot of people, I know I definitely do the same thing. I will pick up random objects that catch my eye and stare at them. And, me and my wife have been married long enough. She knows what I'm doing now. Again, early in the marriage, very similar. Like, why are you staring at this simple trinket, toy, mechanism, whatever it is? Pick up a bolt off the street and see if it was maybe machined, see if it was rolled, see if it was stamped. Right? How did all this stuff come together, and identify that kind of stuff and who put the time into it? It's a lot of fun for me. And so it's fun to find other people on that same wavelength. We can have these conversations, and LinkedIn's an awesome place to do it because it reaches a whole lot of people, and we can have these type of very nerdy conversations about stuff that we're passionate about. So
that's right.
It's an awesome platform to be able to do that. Also built by engineers.
That's right. 100%. Well, we've learned a lot about, Andy, the engineer. And I've got a few more questions that just probe a little bit into not necessarily Andy, the engineer, but Andy, the person. And I'd love to learn a little bit more there. And you can take these questions any way you want. You can take them, career professionally. You can take them more personally, whatever you think is going to be interesting and useful for the audience here. So the first one, if you magically had an extra 20 hours per week that you could spend doing whatever you wanted and it would not negatively impact any of your other responsibilities, what would you do with that time?
Yeah. There's obviously things like, friends and family is one of the big things we'd all love to spend more time with. Right. And that would certainly be a great and worthwhile thing to do. But if we're just playing with thought experiments and what industrious thing we might do with an extra 20 hours, right? I think I would like to see something like maybe dedicate half of that time to that networking and communication side, right? Not just on LinkedIn. Find actual events or conferences or things that you can go to engage with like-minded people, even we'll say adjacently minded people about maybe some different subject matter, and find different ways to utilize their skill sets and find ways for them to utilize your skill sets. That communication and collaboration is a huge tool that I think the engineering community is unfortunately underutilizing. A lot of it due to that kind of personality that we talked about. And then I think, I would love to be able to spend more time with those standards that we talked about, right? I have very good understanding of the handful of standards that I've used and gone over and well, not memorized, but read through thoroughly and made sure I understand every sentence, every figure, and to expand that into things where, I have some experience in metrology. I'm not a metrology expert, but I'd certainly love to get more into what happens with that, right? Learn more about what happens and how things come together with, say, surface texture measurement, right? Surface texture is its own microcosmic universe that is very much not understood. At least I don't understand it very well. I think engineers in general don't. But how much that surface texture, surface roughness plays into the design of our world, right? It drives things like, it drives friction, it drives fatigue. It's so much. And it's a fun world to sit and think about. So try and split that time between learning those new engineering skills that I'd love to just bury my head in for a while, if for nothing else, for the academic fun of it, and then spend the other half really networking, connecting, talking with people, whether it's, mentoring younger people, even mentoring, like you say, even older people, less experienced people, right? I love to connect with some of them, because a lot of times that, why are you doing this question that a person who hasn't been in the industry for a year that everyone else takes for granted makes you step back and address and think about it just a little bit different, right? This is where we can switch from incremental improvements into current product and process to leaps forward and transformational changes from the right why at the right time.
Great answers. What is something that you've always wanted to do, but for whatever reason haven't?
I think for me personally, and this is more a statement of priority, I would love to learn a new language, right?
Okay.
A foreign language of some kind, I think would be a lot of fun, because it requires not just that academic learning. You sort of have to be immersed in the culture a little bit to really understand and master the language, learn how to communicate with the people verbally and non-verbally. Like, that would really be a lot of fun, but it takes an incredible amount of time if you are not, for lack of a better term, dropped in the middle of that culture and forced to learn it. To learn it passively is a very difficult thing to do. And so I've never set it as a high enough priority, but it would be great fun to be able to do that.
Any language in particular that you think you'd start with?
I think here, so I'm in Utah. Probably one of the most useful would be Spanish, right? We have a lot of Spanish speakers here. We have a lot of that kind of heritage around here, and working in manufacturing, we work with a lot of people that speak Spanish, and it would be awesome to be able to communicate with them. A lot of them speak English very well, some of them not so much, but be able to communicate with them more directly would really be a good thing, and go back to that collaboration that I talked about, right? If you can communicate with people in a language that is easier and more effective for them, the conversation can be more productive for you as well.
Yeah. Have you ever heard of Duolingo?
I have, and I tried my hand at it, and it just becomes another one of those, priority shift, right? Between the full-time day job, side projects, trying to keep things like LinkedIn and other networking events involved, I simply have not prioritized it where I need to be effective at it.
Only so many things that you can do, right? All right. Well, Andy, I think we'll wrap things up there. What a great conversation. Thank you again for being on the show today. Any final thoughts that you'd like to leave us with?
I think kind of one thing I would like for engineers to understand, especially as we're talking about collaborative design for manufacturing, is I think one of the keys there is identifying your manufacturing process early on, right? When we start looking at a design, something like material selection plays a huge part in what we design. Are we going to use aluminum, or are we going to use steel, right? If we're going to use aluminum, are we using 70-75 or 60-61, right? And those very granular definitions may not be available at the very beginning, but they should be, we should be able to categorize them very early on, right? We're going to design an aluminum structure very different than a steel structure, right? So similarly, if you're going to design a machined part or a cast part or a part made with additive manufacturing, right? The earlier you design that, or the earlier you learn that that's your intended process, the sooner you can take advantage of those inherent pros in that process in your design, right? If we've designed a good machined part for a machined process, right, we've optimized that design kind of right out of the gate. If we're taking a machined part and now we're going to cast it, or we're going to try and build it through additive manufacturing, it's not just a plug and play scenario. So I like to help people understand that very early on. So as a final closing thought.
Thank you so much for sharing that. All right, Andy, how can people get in touch with you? Yeah,
I mean, we've talked about LinkedIn pretty extensively. That's probably the most common way. As you said, I'm out there with kind of weekly posts. Try and engage with anyone who has questions, sends me messages, whatever it is. So yeah, that's probably the easiest way. That's the only version of social media that I find myself on. Beyond that, no, let's just stick with LinkedIn, because that's going to be the most successful way. And happy to answer questions, engage with people, and help people, kind of learn about this powerful tool and the collaborative methodology that I like to try and bring to the table.
Phenomenal. Andy, thank you so much for being on the show today, and thank you for everything you do for the engineering community.
Yeah, thank you, Aaron. This has been a whole lot of fun. Appreciate it.
I'm Aaron Moncur, founder of Pipeline Design and Engineering. If you liked what you heard today, please share the episode. To learn how your team can leverage our team's expertise developing advanced manufacturing processes, automated machines, and custom fixtures, complemented with product design and R&D services, visit us at teampipeline.us. To join a vibrant community of engineers online, visit thewave.engineer. Thank you for listening.